So as per the discussion before, so we are using this equation or decomposition or matrix factorization equation in order to reduce its dimension, right? So we are trying to reduce the dimension of this matrix into a lower dimension, and we are using this concept of getting the rank of the matrix, and we are multiplying them individually by decomposing it to a singular matrix and multiplying them back and getting the original matrix with a lesser dimension. So this whole process can be explained in other physical terms or other pictorial representations, which I am going to explain you in this way. So consider this whole matrix or the occurrence matrix, say A. This matrix initially will be having a higher dimension. Higher dimension are nothing but it will be very sparse, or it will be containing very noisy terms or noisy columns. So we are trying to remove that high dimension to a lower dimension through that factorization method. So what we are trying to do basically here is, so suppose say there are two vectors which I am pointing here, 1 and 2. So I am trying to project these vectors to a lower dimensional space in this way. Say take a 3D object on the left hand, and if you try to beam a light on that 3D object, then if you beam that light and that shadow of the object will be aparted or imparted on the two-dimensional screen. So suppose if you take a light on the left hand side, and if you hold an object in front of it, a 3D object, then the shadow of it will be falling on a 2D space. So by this, the 3D object will be converted into a 2D space, right? So by this, what is happening, the points which were far apart in the 3D space or in the 3D dimension would be coming closer together on a 2D space. We are trying to remove certain dimensions, right? We are trying to chop off certain dimensions so that those 2 points will be coming closer to each other. Fine. So it is as simple as that. So if you take a 3D object and if you project a light on that, the points which were farther to each other were apart. After converting into a 2D object or a 2D shadow, then those 2 points would be appearing closer together. So the same process, here we are projecting this higher dimension 2 vectors to a lower dimension vectors, and we are computing the new distance here, or we are computing the lesser distance here, and we are trying to project them back to the 3-dimensional space. By this, all the noisy terms or the noisy expressions or the noisy values which were present in the higher dimension are completely reduced. So say there was a value of 5 and 6, say I am like explaining with a gross terms, that is, say there are values 5 and 6 and they are projected here on a lower dimensional space and projected back to the 3-dimensional space, then the values would have not be the same 5 and 6, it would be reduced values. That is what whole this factorization matrix singular value decomposition are doing. So the final LSA or the latent semantic analysis, what it will do, we are trying to get a lower dimensional matrix, right? So even after projecting from a higher dimension to the lower dimension and projecting back to the higher dimension, there are certain vectors in the high dimension space where the values remains unchanged. It will be remaining the same value. It will be having the same value even after projecting to the lower dimension and projecting back to the higher dimension. So all those vectors are generally singular value vectors or singular columns. The similar way, it will be of a singular column in this way, like one of the column in the U M cross R. So these singular value matrices will remain unchanged. So thus the term SVD or a singular value decomposition, which we are trying to do here. So what is a major advantage by doing this? The first thing, we are trying to reduce the dimension or trying to remove the noise or the sparseness of the raw matrix, that is occurrence matrix. We will be reduce the dimension of that. The second thing, as I mentioned in this example, that is this man and footpath in say context 1 C1, in the context 2 C2, the same words like man is used as a pedestrian and the footpath is used as a sidewalk. So there were enough distance before. So the matrix which we formed, or the occurrence matrix which we formed, we'll be having a word like this with a farther distance. But by after reducing these, the dimension of these using the singular value decomposition, then these dimensions, or these dimensions between the man and pedestrian, would almost will be reduced to zero. By the sense, these man and pedestrian will be having certain correlation between them already. So by this we are trying to eliminate the additional columns or additional values which were present in the original raw matrix. This is all about LSA. So in the further session I am going to explain you merits and demerits of the LSA.